Next, we have two speakers or two talks. The first one is about, or the title is "For the First Time: Start to Code, Test, Package, and Publish Your First Library." So about creating your first library. This is also a pre-recorded talk, but the speaker will be available for questions online after the talk, so please remember to post your questions. The speaker is a test manager at DB Schenker and a regular robot framework user since 2020. Let's enjoy the talk by Mani Kasiriha.
Hey everyone, hey RoboCon. This is Manny. I wanted to speak with you how to release a library as open source, especially a robot framework library. Because that's something I did last year, and for me it was quite a mystery until I did it. So last year I developed some library, or it was a loose collection of Python files to be honest, for robot framework for my company. And we decided might be useful for other companies or other people as well. So we decided to release it as open source. But then what? It was just a loose collection of Python files. I didn't know how to do a pip install something. So I needed to investigate a lot. And I thought maybe this is also interesting to you. Let me quickly introduce myself. My name is Mani Kasiria. I'm a QA engineer at DB Schenker. That's a global freight forwarder. And I'm a robot framework user since about 3 years. Now, when I decided to release my work as open source, first I was a bit afraid. I don't know, maybe it's a German thing, this German angst. We are afraid of the weirdest things. So I was afraid, what if nobody needs it? Or what if I deliver a mess? Or if I forget something essential, do I look like a fool? In hindsight, I can say you definitely don't need to be afraid. Because the thing is, releasing anything is better than releasing nothing. You will also learn a lot along the way. I also learned a lot. And if you deliver a mess, you can also yank a release, so remove a release from PyPy, so it's no problem. And I can recommend just release in small pieces. And I can also say the community is quite helpful. So be it the Slack, when you ask a question there, or when you get some issues via GitHub. I haven't met a root developer so far, so maybe I was just lucky. So let's start with the question, what do I want, or what did I want at that time? So first I thought, open source project needs a GitHub repository, right? So I wanted a simple GitHub repository with a simple structure, with some documentation there, a README file, so people should know what this project is about, how to use it, how to install it, how to get started, stuff like that. Then, of course, for my library, I wanted it to be installed via pip, because that seemed very far away at that time, but it's a common way to install robot framework libraries. So pip install and then robot framework, my library name. And of course, all the dependencies should also be installed like that. And afterwards, I just wanted to use it directly in robot framework. So via library, and then importing my library name. And afterwards, I wanted to be able to just use those keywords. Pretty simple, but very far away for me. And as a robot framework user, I know that a library is useless without a proper keyword documentation. So I also wanted to make sure I have a keyword documentation with all my keywords documented. So with the arguments, what they do, what they return, and also some examples, stuff like that. And I think that's already 3 things I wished for and that I wanted. So let's quickly see how we can fulfill those 3 wishes. So what did I need to do for that? Before we start, one small thing which always confused me pretty much in Python, because I don't know Python that well, honestly. So there's a thing, there's this distribution name for your package. And for robot framework libraries, that's normally robot framework dash and then the library name. So that's the distribution name. You will install your library via pip that way. But then there's also the package name. So that's the name that you use when you load it into Robot Framework. And this package name is just your library name in camel case. So when I import it, here in this example, it's library, then my first library. That's how I load it into Robot Framework. Now this Python package, this my first library, so this is actually a folder which contains multiple Python files, so multiple Python modules. In my case, in this example, I would just have a single module, but it could be multiple. And inside those modules, you will have classes. At least normally you will use at some point a class. And one of those classes should have the same name as a Python package. So if your library is called my first library, there should be a class my first library. And this will make your life easier when loading it into Robot Framework. Let's have a quick look at the code of my library, how it looks like. So this library is about finding faces in images. So it will have some dependencies to an image recognition package, OpenCV. And it's pretty simple. Apart from that, it's a single Python module with a single class. And yeah, as I said, main use case, finding faces. Now about this keyword documentation topic. Let's quickly speak about that, because we are speaking about coding. Nowadays, you include the documentation inside the code. That's also a thing which confused me back then. I have never done that. I was always wondering, why do people add so many comments into their code? And the reason is you can generate the documentation out of that. So you can add those comments as doc strings, and you can add them at different places. For example, at the class level, you can add a doc string. And later you can run a command robot libdoc, and this will create the keyword documentation. And whatever you write in the class will be the introduction of your keyword documentation. Whatever you write inside the keywords will be the keyword documentation later. Yeah. So, and afterwards you can host it on GitHub pages. So pretty straightforward, but I didn't know it back then. Then, of course, if we want to install something via pip, we need to first get it there and build a package and deal with the dependencies, publish it. So I did some reading and on some Python pages. So there was something mentioned about a setup CFG file, setup py, and also something, what was it? Py project.toml. I'm not sure. But anyways, I was a bit confused. And then a community member, Robin, mentioned in the Slack, why don't you use Poetry? Never heard of it. But then I looked at it and yeah, pretty impressive tool, I have to say. So Poetry can take care of your building of the package. So it will collect some package metadata like the name, the license, the author and dependencies, all that. So it will collect that, the dependencies. Then you can use it to build your package afterwards. And you can publish it to PyPy if you configure it accordingly. And it can also set up virtual environments for you. Yeah, so it will install all the dependencies, create a virtual Python environment for you, which you can use for your development. So pretty impressive tool, I have to say. Here you can see some example commands. Yeah, you can run this Poetry init to initialize, Poetry install to install all the dependencies and create this virtual environment. And then afterwards you can use Poetry run to run commands in this virtual environment, Poetry build to build your packages, and Poetry publish to publish your packages to PyPy. So pretty cool. So I would say that's enough. So let's have a look how this looks like in reality. So that's the folder structure I have for my project. If we take a look, so the A test folder is used to store the acceptance tests, the docs folder to store documentation like keyword documentation and the README file. Then we have the face library folder, that's the Python package, which contains our files for Python and everything else for the library. And the utest folder, which contains the unit tests. Then we have some separate files in our main folder, git ignore. This is to ignore some files generated from GitHub. The license file, so for the license, here it's an Apache license. And the tasks, we will come to that later. But the most important one is the pyproject.toml, because that's a file which is generated from Poetry. And it will contain some metadata for our project, like the name, the version, description, license, where to find the package. And it also contains the dependencies. Yeah, so dependencies to operate this package, but also dependencies for development, so to build and test that package. Now, this file is already defined. There is a wizard for Poetry to generate such a file. So if I now just rename it, Toml, rename it to old, I could now run Poetry init, and then Poetry will start this wizard and ask me some questions about the library, and I could now go through it and confirm stuff. It will even allow me to add my dependencies. Then it will create a new PyProject Toml. I won't do that right now, so let's terminate and rename it back to pyproject.toml. Typo, toml. Okay, so now what I want to show you, when I have this pyproject.toml, what I can do is I can say Poetry install, and then Poetry will install all the dependencies from my file, and it will create a virtual environment. Now there was nothing to install, but normally it would download all the dependencies and install them. And after I'm done, I could now create a build and publish that build to PyPy. Let's quickly do that. I will bump the version a little bit. So I can say Poetry version patch. So then it will increase our version from 0.0.1 to 0.0.2. And then I can say Poetry build to build a new package. So it will now create some files in the dist folder. And then I can say Poetry publish, I think was it. So then I can publish it to test PyPy. I need to enter my PyPy API key before in Poetry, but I already did that. So now it will push the package to test PyPy. And if we now check the page of test PyPy, you will see here robot framework, face library. I can view it, and there I got my instructions how to install it, use it using pip. So basically all the package building and publishing is already done now. So let's have a quick look at the source code of the library, which I already pasted here. So we have a single module, facelibrary.py, and inside that we have a class faceLibrary, so the same name as the package name. Inside that class we have an init function which will initialize the class. In there we will load a model for face recognition, an XML file which is also part of the Python package now. And we have several functions which will later act as keywords. So a function is face and image, and two keywords for assertions should contain face and should not contain a face. As we spoke about documentation, let's also have a quick look at the doc strings. So we have multiple doc strings in here. One is defined on the class level. So this doc string here will later go to the introduction in the keywords documentation. Then we also have doc strings for each keyword. So this will go to the keyword documentation of each keyword. You can see here we have described the return values, the arguments. We even have an example how to use that keyword. So this is always pretty helpful. And we also have a doc string at the beginning of the module. So this will later be used to generate the README file. We won't use it right now. So to create the keyword documentation, we will use the libdoc module of robot framework. So we will use it like that, python-m robot.libdoc, and then some arguments. So this will create a new keyword documentation inside the docs folder. Let's have a look. And yeah, so that's our keyword documentation. Now, after I push those changes to my GitHub repository, I need to enable GitHub Pages to make sure that the keyword documentation HTML file can be shown by GitHub. So I can select a branch and a folder which shall be used for GitHub Pages. So I will choose the docs folder, click on save. And afterwards my site is published. So I can basically go here. So nothing is shown, but if I now enter faces library.html, you can again see my keyword documentation. So I could now link to it and it will lead the user to the GitHub page of my keyword documentation. So let's see. Anything else I wanted? Oh yeah, of course. I'm a QA engineer. I need to take care of testing, right? Because I also know that I'm a messy developer, and I don't want to release a mess, so I better test stuff. So let's talk about testing. So as tests, I wanted two types of tests, the unit tests and acceptance tests, because I want to test on those different layers. And in the end, I want to have some test coverage report, just to know what pieces or what parts of my library are covered with tests. So for the unit tests, I need to use a unit testing framework. I used PyTest, but there are also a lot of different ones. And here you can have a look at an example. So it's a Python file starting with test. PyTest will discover such files automatically. And in there I have several tests to cover the keywords of my library. The thing is, unit testing is important because with unit tests you can test things easily, which you can't test with Robot Framework. So just imagine if one of the functions is not a keyword for Robot Framework, but something else. With a unit test, you can still cover it. With Robot Framework, you couldn't. So that's why unit testing is pretty important. And you can sometimes do things easier there at that level. But it's not all. So of course, we also have acceptance tests. And here we use Robot Framework. And in the acceptance tests, we test the library in everyday use cases. So we just import it and then we cover the keywords. Maybe important, makes sense to cover the positive path and the negative. So if your keywords throw some errors, for example, during assertions, then it makes sense to test that as well. So that's it. So let's have a look how the tests look like in reality and how you can run them. My unit tests are stored in the utest subfolder in a Python file test_face_library.py. Inside that file, I have 3 unit tests. Test image should contain a face, test image should not contain a face, and test assertion error should be raised. Inside those unit tests, I check if the function isFaceInImage returns true or false, depending on if a face is detected. I also check positive and negative cases for the functions should contain a face and should not contain a face. I can run the unit tests via the PyTest command or via the coverage package. Via PyTest it's simple, I just need to enter PyTest and the test will be discovered automatically. With coverage, I can run them via coverage run and I can define a folder which shall be monitored for the code coverage. After I executed them with coverage, I can call coverage report to have an overview of the code coverage, and I can execute coverage HTML to also get an HTML file with the code coverage overview. So here we can see how much of our code has been covered by the unit tests. My acceptance tests are stored in the atest subfolder in a simple robot test suite atest.robot. Inside that test suite, I have 3 test cases. Image should contain face, image should not contain a face, and check exceptions. And I'm checking positive and negative cases for the keywords should contain a face and should not contain a face. I can execute the tests via the robot command on the command line. So, but that's all right. We got our code, our package, our tests. Well, here's the thing. I'm a very lazy person and I don't like to do tasks again and again. So let's speak about making our life a bit easier. So first, we now got a lot of tasks that we need to run again, like running the tests, creating the documentation, creating the README, creating reports. And I don't want to type so much in Python, yeah? The thing is, there is a Python package invoke, which will allow us to define tasks easily. So we can define those tasks in a Python file and add a task decorator to them. And afterwards, we can run them very easily using the command invoke. So you can say invoke tests to run your tests, invoke libdoc to generate your documentation, or invoke readme to generate your readme, or invoke publish to publish things. Yeah, so that makes your life a lot easier. Then the other thing about automation, there's also GitHub Actions. So if you don't know, so GitHub Actions will allow you to run jobs on certain events. And those jobs will not run locally, but on the GitHub infrastructure. And what you can do is you can run jobs, for example, when you push code, when you merge, or you can also run them manually. And you can do things there like build your package, run your tests, or even publish your package. Yeah, so you got a lot of things you can do. You can even do like continuous deployment. So when you push something and the test pass, you can deploy it automatically to PyPy. So a lot of possibilities. So let's have a quick look how those two things look like in reality. Here on the screen you see an example tasks.py file which has several functions with a task decorator. If I want to execute one of those functions, for example tests, all I need to do is say invoke tests. Let's give it a try. So, this was all which was needed to run our unit tests, our acceptance tests, and generate a report from coverage with the code coverage. In the same way, I can also create the keyword documentation. So, that makes our life a lot easier. So let's have a quick look at GitHub Actions. You can define or add new workflows in the Actions tab here. You can add a new workflow, and GitHub will offer a lot of templates, yeah, like publishing Python packages, building Python packages, and so on. Right now, we already have a workflow defined to test things. We can have a quick look at that. It's basically a YAML file, and I won't go into detail, but what this one does is it will run on every code push, and it will install Poetry, install the dependencies, and then run our tests. And let's quickly give it a try. So what we will do now, I will just change something here in the code directly in my editor. So I will just change the, I don't know, the version to version 3. Okay, and then we can already see here in the Actions tab that this test workflow is now running. And it goes through the sub-steps here. It will install Poetry now, and in the end it will run the tests. So there you can see the test results. Everything passed. That's great. We could now store those results as an artifact and download it later, but I just wanted to show you how it looks like when a job is executed from GitHub. So we're almost coming to an end. And unfortunately, there are a lot of things I could not cover during that talk in detail. But I set up a GitHub repository for that. So if you want to know more details, check out that GitHub repository here, and you will find more detailed steps and other things you can do. So I couldn't speak at all about the different library types in Robot Framework, like dynamic, hybrid. There are a lot of other helpful things like keyword decorators that you can add to your keywords. There's things like managing releases and versions, also in GitHub, using branches, merging, pull requests, and much, much more. Yeah, so you need to do some reading yourself. But I hope my talk allows you to get started and will enable you to release your work, especially your Robot Framework libraries as open source. So I hope it was helpful. Feel free to reach out to me. You can find me on the Slack channel, on GitHub, on Twitter. Yeah, so my name is pretty unique, so you will find me. And with that, I will end the talk. So thanks a lot for listening. I hope you enjoyed it, learned something, and yeah, have a good day. Stay safe and see you soon. Bye.
Mani Kasiriha. Once more, thank you. Thank you. I have to mention it, your Twitter handle, really nice.
Thank you. Hey, everyone.
Hey, we have a few questions for you. Must the file name be the same as the class name?
Honestly, I also had to search in the user guide for a moment, so I just followed a recommendation from the user guide where this was said that the class name should be the same. But I'm pretty sure there are also ways around that. I just tried to follow that practice from the user guide, and I put an answer in the chat.
Good. How about, well, this was probably like a more all-around question, but anyone know if Poetry and GitHub Actions work together, but you actually had at least the installation there?
Yeah, so it worked. I did not do it in the past, but in the talk you can see an example of that. Yeah, definitely works.
And I think this was kind of like an interesting question. Why not use RPA feature of robot framework to automate your tasks to package and generate the doc and deploy?
Yeah, a good question. Maybe I need to investigate if I can use RPA framework as well. For now, I just stick to simple Python with some small packages like the invoke package. But yeah, the more complex it gets, maybe I need to also use RPA framework. Who knows?
Do you have any advice for best practices on logging from library like this?
Yeah, so Robot Framework also has an API for logging. So I put an example in the chat, and you can also use this API to write log messages. I think that's the only recommendation I would have right now. Yeah.
Yeah. And general question: how do you version your test scripts?
Yeah, of course, when I want to develop my scripts, I would also need to manage, or when I develop my library, I need to manage my tests as well. So I would say same along with the source code. If I develop for release, I also write the test cases for that release. I don't know. Maybe other people have different opinions. I would just develop it along with the library
I think we
itself.
can continue on that in the chat. One more question.
Yeah.
So can we package files having common keywords for UI automation, which can be used by other projects?
That's a good question. I think you can package everything in there. I think Robin is more of an expert. So Robin McKay, ask him about packaging and poetry. I'm pretty sure he has some good ideas about that. I would say, why not?
Yeah. Hey, once more, thank you, Mani Kasiriha, for the awesome presentation.
Thanks a lot.
Thank you. Bye.